So today we are going to learn gravitation. The first topic in gravitation is Newton's laws of gravitation. Newton's law of gravitation, what does it tells? It tells that every particle of matter in the universe attracts every other particle with a force. Right? This force is directly proportional to the product of the masses of the two particles and inversely proportional to the distance between them. And also this force acts by mistake acts along the line joining the two particles. For example, if I draw two bodies, one body and second body, and if the mass of this particle is small m and the mass of this particle is capital M, and the distance separating them is capital D, then according to Newton's law of gravitation, these two bodies will attract each other with a force, and the value of this force will be proportional to the product of the masses of the two bodies, right? And this will be inversely proportional to the distance separating the two particles or the two bodies, right? So, and it will act in the straight line joining the two particles. So we can write F is equal to a constant which is known as capital G, small m, capital M by d square. Now, this is Newton's law of gravitation, and this constant is known as gravitational constant. This constant is known as gravitational constant. Now, many times you may be asked to find out the unit and dimension of this gravitational constant. So, how you can find out the unit and dimension of this gravitational constant? Now, from here you can write G is equal to F into D square by M into M. Now, the dimension of force is mass into acceleration, mass into length into e to the power minus 2. What is d square? D square is again L square. D square is L square and divided by mass square. Okay. So the dimension is m to the power minus 1 L cube t to the power minus 2. So this is the dimension of gravitational constant, and the unit you can find out by per kilogram meter cube per second square. Okay. My mistake. It is by m square. No? So m to the power minus by m square. Okay. M to the power minus 1 L cube to the power minus 2. So the unit is per kilogram meter cube by second square. Kg to the power minus 1 meter cube and second square. Okay. This is the unit and this is the dimension. Now, what is the definition of gravitational constant? The definition of gravitational constant, suppose there are two bodies of unit mass, which means small m is equal to 1 and capital M is also equal to 1, and they are separated by a distance of 1 meter and they are separated by a unit distance. So D is also 1. So then this small m becomes 1, this capital M becomes 1, and this E becomes 1. So F is equal to G or G is equal to F. So we can write that gravitational constant is the force of attraction. Let me erase something so that we can write. Yes. So gravitational constant, what is gravitational constant? Gravitational constant is the force of attraction between two bodies of unit mass separated by a unit distance. So this is the definition of gravitational constant. It is the force of attraction between two bodies of unit mass separated by a unit distance. The next topic of discussion is gravitational attraction of Earth or gravity. Now, the force with which the Earth attracts every body on or near its surface towards its center is called gravity. Right? The force with which the Earth attracts every body on or near its surface is called gravitational attraction of the Earth, or in short, gravity. Or in short, gravity. Earth's gravitational attraction, in short, is known as gravity. Okay. So, have you understood gravitational attraction of Earth or gravity? It is the force with which the Earth attracts every body on or near its surface towards its center. Okay. So we can write, we know from Newton's law of gravitation, F is equal to G M by d square. Now, this is the force with which Earth attracts every body towards itself. So this force is applied on all bodies. So what is this force? M into G. G is known as acceleration due to gravity. G is known as acceleration due to gravity. This G is known as acceleration due to gravity. We know that force by definition is mass into acceleration, and this is equal to G M by d square. So mg is equal to gmm by d square. From here we can cut m from both sides, mass of a body, and g will become g is equal to gm by d square. Gm by d square. Gm by d square. So if you know the mass of the Earth, see this mass of the Earth, this g and d, all you can find out. Now what happens is that the bodies, in the definition of gravity, I have mentioned that the Earth attracts all the other bodies which are on or near its surface. If they are on or near its surface, and it attracts towards its center. So if this is the Earth, right, and there is a body here, it attracts it towards its center. So what is the distance between the body and the Earth? The distance between the body and the Earth is nothing but the radius of the body. So we can replace this d with the radius of the Earth. So g becomes almost equals to capital G m by r square. Capital G m by r square. Now this gravitational constant is a constant. Mass of the Earth is constant, and this radius of the Earth is also a constant. So this gravitational attraction of Earth, acceleration due to gravity, g, becomes constant, and its value is 9.81 meter per second square, or for doing numericals you may take it as 10 meter per second square. Okay. Now we can replace this capital M, mass of the Earth, with its density. Let's see how we can write it by volume into density. So this gmm by r square, we can write, instead of m we can write g into volume of the Earth. Volume of the Earth, since Earth is taken as a sphere, 4 by 3 pi r cube, 4 by 3 pi r cube, into rho, which is the density of the Earth. Rho is the density of the Earth, divided by r square. So finally the expression that we get is 4 by 3 capital G pi r into rho. Pi r into rho. So G, the question may come whether G is proportional to R. G is proportional to R, or G proportional to 1 by R square. Right? Whatever, which one is correct? It may be asked that if G is whether G is proportional to R or whether G is proportional to 1 by R square. Then it will depend on the whether mass remains constant or whether we are considering the density, whether we are considering the density or whether we are considering the mass of the Earth.